Welcome to the Oxygen Assist module in service video. My name is Ashley Welsh, Product Manager here at Vapotherm. Today you will learn about the Oxygen Assist module, or OHM, for Vapotherm's Precision Flow system.
The OHM is an optional module used only with the Vapotherm Precision Flow to aid clinicians in maintaining a patient's target Spo2. It uses a proprietary feedback control algorithm to monitor a patient's oxygen saturation and automatically adjust the oxygen concentration provided by the Precision Flow to maintain the patient's Spo2 target as set by the clinician. Today, we will review the Oxygen Assist module and how to set it up on a patient. Before starting the OHM's closed-loop control, please titrate your patient's high-velocity therapy manually to effect, comfort, and Spo2 stability. When you decide to use the OHM's closed-loop control, please connect an Spo2 probe to your patient, connect the probe via cable to the OHM, and plug the OHM in or switch it on using the on-off button on the front. The OHM will boot into the home screen. The first thing you'll want to do is go to the patient screen, where you can enter all therapy, backup, and alarm settings. You can choose between 4 patient populations. These patient populations impact the preset defaults only and do not impact any behavior or functionality of the algorithm itself. To change any settings, touch the parameter box using the touchscreen, then use the blue control knob to adjust the value. Let's start with the Spo2 Target. This is the target that will drive the controller's decision to adjust the O2. It is the foundation for the therapy. Next is the Spo2 Target range. The target range does not impact the controller. It is only for numerical and graphical display of the time in range. Next is the backup O2. The OHM adjusts the Precision Flow's O2 to keep the patient in target Spo2 by using the measured Spo2 from the patient. If the system does not know the current Spo2, it is unable to make decisions and adjust the oxygen. In the case of a signal loss due to probe disconnect, Spo2 interference, or low perfusion, for the first 2 minutes of signal loss, it will continue to deliver the last calculated O2. A silent advisory message is displayed. Should the signal loss persist longer than 2 minutes, the alert turns into an audible alarm and the O2 delivery is set to fallback mode. The fallback FiO2 will either be the set backup O2, the average of the last 3 calculated values, or the average FiO2 since auto mode was started. OHM chooses the highest value of the 3. The last value is the highly clinically relevant O2 alarm limit. When you manually adjust your patient's O2, you will be notified of any deterioration or increase in O2 demand by an Spo2 alarm on your multi-parameter monitor. You react to this alarm and recognize the change in your patient's oxygen demand. This does not necessarily happen in automated O2 control. The controller adjusts the oxygen to the patient's needs in order to keep as close as possible to the set Spo2 target. To make sure you are notified of an increase in oxygen demand over time, you need to set this O2 alarm limit. As soon as the oxygen delivery exceeds the O2 alarm limit for more than 2 minutes, it will trigger an alarm and notify you of this change. From clinical experience, we suggest this is set approximately 10% above the mean O2 and regularly adjust to the patient's situation. The O2 alarm limit is an alarm only, and it does not prevent OHM from increasing the O2. Once you have checked and adjusted these settings to your patient's needs, press Start Case. At this time, go back to the home screen and observe both Spo2 readings, the one on your Oxygen Assist module and the one on your multi-parameter monitor, to make sure the readings are closely matched. Do not expect to always see the exact same value, but if the drift is too great, please reposition the probes. On the patient screen, start auto mode. The controller takes over immediately. Look how quickly OHM decreases the O2. This is because the patient is above target and OHM tries to wean the oxygen. On the home screen, you can see that the module is now in auto mode and that the patient's target SpO2 is set to 93%. These boxes also act as shortcut buttons to quickly move back to the patient screen. On the home screen, you can also see the patient's real-time SpO2 and your O2 alarm limit. The delivered O2 is displayed by the precision flow. Using an Spo2 simulator, I'll trigger now a desaturation event so we can see how ohm and the precision flow behave. The patient's SpO2 is measured continuously, and the algorithm makes adjustments based on a 10-second cycle. As you can see, the ohm reacts to the dip in SpO2 and increases the O2 on the precision flow accordingly. Now I'll have our patient respond and increase the SpO2 back up to 95%. As the patient improves and rises back above the set Spo2 target, the oxygen is again adjusted and the precision flow now delivers 21%. The trend on your home screen is set to a 60-minute scale that can be changed to 15 or 2 minutes. For typical use, we suggest the setting of 60 minutes. In the upper left corner, you can see the mean O2 displayed. This is the mean O2 delivered over the displayed time. We suggest using this value for documentation of your hourly observations. Due to possibly frequent and significant changes of the delivered O2, the precision flow display of O2 can only be a snapshot. The mean O2 on the ohm represents the real mean of the last 60 minutes. On the home screen, you can also see the dotted red line, which represents the set O2 alarm limit. On the trend screen, you can review data over time. This screen is showing a 24-hour trend, and you can move through time using the settings control knob. The mean O2 and the time in range are automatically calculated based on the displayed data. Use the blue control knob to slowly browse through time. Press scroll. You can see it changes to page to browse through time screen by screen as indicated on the timestamps. You can change the x-axis to see 2 minutes up to 72 hours of data at a time. Time in range as well as the mean O2 always refer to the time period that is displayed. If you want to override the O2 delivery calculated by ohm, you can do this at any time simply by using the Precision Flow's control knob. The override mode will be displayed in the mode button. Auto mode will be restarted automatically after the preset time. On the system screen, you can change the revert to auto time as well as other system settings such as time, language, volume, or display brightness. You can also use this screen to update software, download case data, or change your PIN codes. If SpO2 signal is lost, you can see an advisory message on the top of your home screen. As discussed earlier, the O2 is paused at the last calculated value as displayed in the mode button. If this situation persists longer than 2 minutes, you will get an audible alarm and ohm will deliver the fallback O2. If the signal returns within these 2 minutes, the algorithm will take over again, clear the alert, and calculate an appropriate O2 value. Please always remember that ohm is a controller, not a monitor. You should always continue to use your primary patient monitor for SpO2 alarms. Check your backup and alarm settings on a regular basis, and also regularly check that your 2 different SpO2 readings are closely matched. Do this particularly after manipulation of the probe sites. If you see a significant discrepancy, please reposition the probes. Should you want to take over manual control for a longer period of time than the revert to auto is set up, just go to the patient screen and change auto mode to manual mode. All alarms will be silenced and you have full control over the O2 using Precision Flow. To discontinue therapy, first place ohm into manual mode, then end the case. The case data will be stored internally and trends will be cleared when you start a new case. Next, remove the sensor from the patient, power off ohm, and wipe the unit as well as the cable with approved disinfectant wipes. Ohm is now ready for the next patient. Thank you for watching this in-service for the Oxygen Assist module. For any questions, please visit us at www.vapotherm.com.